Hello. So, welcome again. We are going to do a second experiment this time, which will combine chemistry, some physics, and a touch of, genuine regular creativity, you could say, making simple, cool outcomes out of remedial objects, let's say. So we're basically just going to make a lava lamp. I know they're not the rage as they once were, but we're going to make one by using just a few simple ingredients and kind of dash of scientific conceptions together. So let's just jump in, and this will all revolve mainly around limiting reactants. Uh, so what will we need for this? Materials. We'll need water source. We have oil. We'll need oil, vegetable oil, mineral oil. Go vegetable. Um, Clear container or bottle. I'm just using a bottle. I have the camera here so you can see the whole thing, obviously. It's a down a bit low. Alka-Seltzer tablet. Got mine over here to the left. And many other people do stuff like dyes and stuff, but, too busy, We're adults. We have things to do. But let's go through it. So, let's walk through the steps of now creating it ourselves. So, let's begin by filling up the clear container or bottle, about 1/4 of the way with water, and this will be our base layer. I gotta, concentrate. My measurements aren't always the greatest. Okay, I'll dump just a tad little. Kind of looks like 1/4 to me. And then we will be getting the oil on top. So what will the oil do? Let's see. We'll know that they don't mix to start. Watch this. Look at that. You'd argue it's kind of like a dye of its own already. It's like a yellowish lemon or something. Cool. So it'll mix. You can see between the two of them. They kind of. Let me just wash this off. They separate instead into distinct layers due to their different densities. And now comes the coolest moment of all, arguably. Let's add the Alka-Seltzer in. Right here. You ready for this? Then we'll talk all about it. It's awesome, right? It's kind of mesmerizing. Okay, so let's talk about all this when this happens. The key to this mesmerizing lava lamp effect lies in the chemical reactions. Let me make sure this doesn't boil over or anything. And the chemical reaction between the Alka-Seltzer tablet and the water. When the tablet comes into contact with water, it undergoes a reaction that produces like carbon dioxide gas, which you see. This gas, these like gas molecules gather as bubbles, as you see, and sorry, my voice. Gather as bubbles, as we see here, and attaching themselves to like the oil droplets in the container. So the Alka-Seltzer droplets go down carbon dioxide and instantly grasp to the oil droplets, gathering as bubbles. And the gas bubbles are hydrophilic, meaning they are attracted to water, which is obviously very useful in this case. And they carry the oil droplets along them as they rise to the top. That's why obviously you see the oil bubbles. It looks like oil bubbles going to the top and then down. It's cool. And the oil and water don't mix because of their different polarities. We know polarities being apart, more polar. Oil is nonpolar, repelling water molecules, while like carbon dioxide bubbles are polar, attracting water, hence this reaction in its entirety. This contrast in behavior leads to unique separation in depth and movement of the oil and water layers, creating their captivating lava lamp appearance and effects. So let's talk a little bit about the main topic in this, which is limiting reactant. And in every chemical reaction, there are reactants that get used up and others that remain in excess. The reactant that gets consumed first, limiting the amount of product that can be formed, is known as the limiting reactant. In our experiment, the Alka-Seltzer tablet is the limiting reactant, as it reacts with water. It produces carbon dioxide gas, although all the Alka-Seltzer, once it's all used up, the production of the gases ceases indefinitely and immediately almost, and the reaction slows down when there's no more Alka-Seltzer. This eventually leads to the end of the lava lamp effect. It's already dying down a bit. If I added more Alka-Seltzer, it would probably start up again. So, what are some possible issues of this? Because every experiment has its possible problems. If we don't usually see this, and sometimes it can't work, some people don't do it correctly, it could be science, it could be setup, it could be a few factors, but you can always rely on reaction rates, just limiting reactants. It's just that you need to be aware of the distributions between the polarities. So don't add too much oil, too little water. You need to be semi precise with these, because you need to have everything in its being their own ways, their own actors, and coming into play in this. So some people fail because they ignore a rudimentary key player in this, which is an instant fail, because everything needs to work properly together to form these cool reactions. So to wrap it up, since it's semi-simple in concept, what we've created here is more than just a fun visual display technically. That's a visual exploration of chemical reactions and a cool way of looking at limiting reactants in play. By observing this, the captivating effects that this had, and understanding why it occurred, we're getting insight into fundamental practices of science as we go. As I mentioned earlier, specifically what types of science. And that is all about it for now. Thank you for watching, and have a great rest of your day and night, or anything else in between.